Hey everyone! Welcome to Interview Breaker channel, where we tackle questions you might face in a tech interview and go beyond the theory. Today we're diving into a topic that's often overlooked but can make a big difference in certain iOS applications. Today's topic is manual data alignment in Swift. So the question might be, tell something about data alignment, or do you know something about data alignment? Imagine you're working on a performance-critical iOS app. Maybe it's a high-frequency stock ticker or a real-time game. In these scenarios, every byte of memory matters, and even small inefficiencies can lead to performance issues like lag or excessive memory use. And that's where manual data alignment becomes essential. By understanding how data is arranged in memory, you can make sure your app uses memory efficiently, leading to smoother performance. In Swift, most of the time, the compiler handles memory alignment for us. But in cases like this, where performance is critical, it can really help to manage data alignment manually. Here's how alignment works and why it matters. Think of memory like a shelf where you're stacking boxes of different sizes. If you stack them randomly, you're likely to end up with a lot of gaps. But if you're deliberate with your stacking, you can fill the space much more efficiently. Let's take a look at an example in Swift. I'll create a simple struct, some data, with a bool and a string. We'll inspect its memory layout to see how it uses memory. Here I'm printing the size of some data. The memory size might surprise you because Swift is adding something called padding between properties to meet alignment requirements. Let's try rearranging these properties to see what happens. I'll reorder the properties in some data, putting the string first, followed by the bool. Notice that by simply rearranging these properties, the memory footprint changes. This is a quick example of how you can reduce padding by ordering properties based on their size and alignment requirements. This is what we call manual data alignment. For more complex data, like structs with multiple data types, controlling alignment can make an even bigger difference. But let us focus on something easier. Here's an example with a struct that includes both int64 and multiple bool values. In this case, Swift automatically adds padding between the int64 and bool values to satisfy alignment requirements. By carefully organizing properties, you can manage this padding to optimize your memory usage. Just try to change the type of integer to int32 and you will see that not only the total size will be less, but an alignment requirement too. Now remember that alignment requirements can differ between platforms. Here's how to use Swift's conditional compilation to check the platform at runtime. Using these checks ensures that your app maintains optimal memory usage regardless of the device architecture. To wrap things up, mastering manual data alignment is all about understanding how Swift manages memory under the hood and using that knowledge when it really counts. So the key points on that topic will be: memory alignment requirements can affect how your structs are laid out in memory. 2. By carefully ordering properties, you can reduce padding and use memory more efficiently. 3. Use tools like memory layout to inspect alignment and structure sizes. 4. Account for platform differences to ensure your code is optimized across devices. Remember, not every app needs manual data alignment, but if you're working in high-performance applications like gaming or real-time data apps, paying attention to memory layout can make a real difference. Try experimenting with your own structs, use memory layout, and see the impact yourself. Thanks for watching. You know exactly who to send this video to, and if you found this useful, don't forget to subscribe to Interview Breaker for more in-depth breakdowns. See you next time, and good luck with your coding journey.